so this is Chapter 2, Functions and their graphs, I think we're doing. So mostly everything here is graphing and learning about graphs. We want to be able to identify when something is a function. We need to identify the domain and range and understand how an implicit equation may or may not yield a function, which we'll actually talk about tomorrow. Okay, so relations are simply a relation, a set of ordered pairs. They are a set of ordered pairs. They are being, by their nature of being presented together, they are being called a relation. They are related. So an example might be here. This is set notation, and these are just curly brackets. And so anytime you see curly brackets, it really means just the set, the set contained between the brackets, the grouping between the brackets. And so we might have an relation of 0, 2, 2, -3 as an ordered pair, and 4, 4, and 8, -6, for example. So just by the nature of presenting an ordered pair together, I am creating a relation. And that's all it is. I am relating two things to one another just by the nature of putting them together, okay? We have 4 different representations of relations. And the first, we could do a table, which is what you see here, an XY table, table of ordered pairs. We have this mapping. This is called a mapping diagram, are these 2 circles. It's a mapping diagram. We could graph a relation using the Cartesian coordinate plane if we wanted to. And we can create a nice little relation sometimes by using an equation. So for instance, I could write all these ordered pairs in table format. If I wanted to, I would do 0, 2, 2, -3, 4, 4, and 8, -6. Hello?
James, tell us.
Okay.
James.
Sayonara. Go see Miss Russell, please.
Oh, Miss Russell.
All right.
Hey, no. Do not.
Oh.
James. That's his own.
4, 4, and 8.
Yeah, 4, 4, and 8, -6. So I can present them using set notation, a set of ordered pairs, or I could present them in table format. I could also present them using a mapping diagram where we maybe, I'm just going to call this I and O. What does the I stand for? Inputs. Inputs and outputs. If you wanted to, we could use input and output. We could put X and Y, same thing, doesn't matter. And so I could map, let's see, I could map 0 would map to 2, and we draw this arrow. If we have an input of 0, it outputs a 2. If I have an input of 2, it outputs a -3. If I have an input of 4, it outputs a 4. And if I had an input of 8, it outputs a -6. So I could do it something like that. This is a mapping diagram. I obviously can't graph all of these, but again, I could graph a set of ordered pairs. I could graph 0, 2. There's 0, 2. I can graph 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. I don't have negatives in this graph, so I'm just going to graph 2, 3. 2, +3. And I'll graph 8, +6. Just because. I'm not graphing these, I'm just graphing other things. 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. So there we go. So there I have a graphical representation. These are discrete data. Discrete data points. Discrete meaning distinct. They are individual ordered pairs, okay? which is very different than when we graph lines or graph parabolas. When we connect them with a line, then we could write an equation. So if we had an equation, it might look something like y equals -3 x squared minus 7. I don't know. But we can represent relations using an equation as well. And of course, it has a new name if we can do that. Okay, so domain is what? Yeah, Domain is the set of x values. It is all the x values that you're allowed to use. That is what domain is. It is what makes up the x-axis, if we will. What's the range? The set of y values. That if we were graphing, these are the y values that would make up our graph, okay? Maybe you want to think about it as inputs. The input are the domain values, and the outputs is the range. That is the set of all the y values. Inputs and outputs, domain and range, x and y, they all happen to be alphabetical, which is kind of nice to help you remember which goes with which, okay? Domain before range, x before y, it matches up pretty well. So, give the domain and range for number 1 here. What are all the domain values? -1, 7, 3, and -5. Very easy. Now, she has you using set notation, so little curly brackets. Those are all of the x's. What's the range?
-1, 4, 0.
Good. -1, 4, and 0. And do we need to list the -1 again? No. Once is enough. We don't need to be repetitious. We don't like that. It's funny, whenever some people like to say things many, many times. Do you know people like that? They'll repeat themselves 5 times. My mother-in-law is like that. And it's always so funny. She'll say the exact same thing 5 times. And it took me a while, but I was like, you have 5 kids. I wonder if there's a connection there. You had to say it for every single kid? Anyway, I always find that really, really funny. All right. So here we have some discrete data points here. And just to help myself, because I can't really see because I'm old. -3, -4 is this ordered pair. What's this one? 1, -3. This would be 2, 0. Here I have 1, 2, and this one is -1, 5? Yeah, -1, 5. Okay, so now that I have all those ordered pairs listed, what's our domain? -3, -1, 1, and 2, okay. And what's our range? -4, 5. I'm gonna do them in order. -4, -3, 0, 2, and 5. 0, 2, and 5. Ooh, curly bracket. All right. So all the y values, it's nice when they're in order. They don't have to be in order, but it is nice that we put them in order. All right, over here in letter 3, we have, what are the domain values? Yep, -2, -1, 0, 1, and 2. And what are the y values, or the range values? Damn it, answer my own question. 0, 1, and 4. Okay, super easy when we have discrete data points, just a relation. So then, we also have to be able to understand domain and range when we're looking at something graphically. And here we have some lovely graphical examples. So we want to give the domain and range for each relation. She's saying in set notation. I really could care less. So domain, when we're looking at graphs, domain is, write this down, how far left and right the graph goes. That is what domain is. How far to the left and how far to the right does the graph go? That's domain. Range is the y values. Our y-axis goes up and down. So if we're asking, hey, what's the range? Then the range is how low and how high does the graph go. All right? So domain refers to the x-axis. You can think like the x-axis goes left and right. So how far left and how far right? So when I look at this kind of interesting shaped graph here, we have this arrow. It's pointing very far down. But is it only going straight down? No, it is not. It is not going straight down. It's pointing down, but it's also going out to the right and to the left. Okay, so it's down and out. It's getting there eventually. Okay, so when I look at this arrow, I have to understand that yes, it's going down, but it is also moving to the left. And this arrow is going down, but it is also moving outward as it goes. Yeah? We're good with that, right? Okay. So how far to the left is that arrow going to go? Infinitely to the left, which would be negative infinity. We are not using set notation. We're using interval notation. Because I hate set notation. It's antiquated. Okay. We're going forever to the left. How far to the right does this arrow go? Infinity. Oh, forever to the right. So domain tells us how far left and how far right. Do I use brackets or parentheses? With parentheses. We can never actually touch infinity, so we can't use brackets. Brackets are for when we're allowed to equal it. All right, so range is how low and how high does the graph go? So when I'm looking, what is our lowest y value down here? Negative infinity. It goes forever down to negative infinity. And then how high does the graph go? What's our highest y value? 6. 1, 2, 3, 4, 5, 6. Right here. Yeah, it goes as high as 6. We have a bracket at 6 because there's these points here at 6 at the top. A parenthesis at negative infinity because we're never going to reach that. Does that make sense to you? Okay, so domain is how far left and how far right. So when we're looking at this graph here, how far to the left are we going? Negative 3. Right here, we get to negative 3. So negative 3 is how far left we get. How far to the right does this go? Yeah, it goes forever to the right. So what do we use at negative 3? A bracket at negative 3 and parenthesis at the infinity. Beautiful. All right, how low does it go? How low and how high? How low does it go? Negative 4. Right here is as low as it goes. It's going down to negative 4. And then how high does this arrow go? Yeah, it goes forever up. So it's going to positive infinity. Bracket or parenthesis at negative 4? Bracket and parenthesis at infinity. Okay? All right, so 3 is a little bit harder. This is a rational fractional function. Okay, we're going to talk more about these parent functions pretty soon. But you'll notice here we have some interesting things going on. And you'll notice at this point, I'm going to do it in red here. Right here at 1, 2, 3, our graph heads to negative infinity, and on the other side it heads to positive infinity. Do you know why it does that? It's got a special name, It's an asymptote. An asymptote, which you absolutely should know from Algebra 2. So we're going to learn it again. But this is an asymptote. It's where our graph diverges. They go in different directions, okay? There's this vertical line right here at x equals 3, where x is actually not allowed to equal 3. We get something undefined, okay? And that comes from a rational function. We'll talk again more about that. So here we get this weird asymptote, this vertical line that we're not allowed to be. All right, our graph is not allowed to be there. So what's the domain? how far to the left does this graph go? Yeah, it goes to negative infinity, okay? And then it comes along, moving along to the right here, and then it says, whoa, hold up. I can't do anything at 3. X is not allowed to be 3. So we're going from negative infinity to positive 3, where I can use every x value in between those. And I cannot use the 3, so we use a parenthesis. And then I get to pick right back up on the other side. On the other side of 3. So 3.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 0.00001. Just right next door. Okay? So 3, again, I'm not equaling 3. That's what parentheses mean. It means super close to, but not 3. Okay, one tiny bit. One infinitely small little piece. Okay? So we pick back up on the other side of 3, and then my graph continues forever to the right, to positive infinity. Does that make sense to you? Yeah. Okay.
Do you not put the brackets in?
We do not use the brackets. If I had brackets, that would mean I would be able to have something on that vertical line. There would be a graph there, but there is not, okay, because you can see how it goes in different directions. Now, the same is true when we're looking at the range. How low does it go and how high? When you're looking at this graph from bottom to top, we see that we have all these y values. This goes forever to negative infinity. It goes down to negative infinity. And then we're moving up, 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 up. And what happens to my graph? It gets very, very close to 0. Very good. And you can see how it's going to, here we get to 0, but it's the underside of 0 to the left. And over here, it's just above 0. You see, so this way is also what's called it's not really an asymptote. We're going to call it an asymptote. Right there, 0, it's diverging the other way. Do you see that? Can you see how they're approaching? One goes off to that, one goes off to that way, and you see they're going up. Okay.
Have the equations where can't equal something is usually number than 0. Like, you know, when there's those equations that are like x can't equal.
Yeah. So those are rational equations, and that's where these sort of come from. This is a horizontal asymptote, and again, because they're sort of going in opposite directions here at 0. From the underside, we move left, and then from the top side, we're moving to the right. So we get this here where y cannot equal 0 in this particular case. Okay? More things that diverge. So again, we go from negative infinity, and we're going up, 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 and we get very, very close to 0. Can we equal 0? No, we cannot. And again, this is we're gonna learn more about this very soon here. And then we pick up on the top side of 0. So on the other side of 0, and then how high does our graph go? Infinite from there. So from the other side of 0, then we go all the way forever up. Okay, so that one's kind of an interesting one. All right, we're going to see some others of those, but let's see here. All right, let's look at a few more of these. Domain and range, again here. This is a lovely, do you know what curve that is? It's a sine curve. Very good, it is a sine curve. So again, how far left and how far right does the graph go? Negative infinity to positive infinity. It goes on forever to the left and forever to the right. Very good. So then for the range, how low does it go and how high does it go? How low does it go? -5? -5, how high does it go? 5. Okay, so -5 to 5. Brackets or parentheses? Brackets, beautiful. We'll come back to 8. What about 9 here? How far left and how far right does this graph go? Yeah, negative infinity. To how far to the right does it go? 0. Yeah, it goes to 0. All right, we've got a parenthesis at the infinity and a bracket at the 0, because it is touching when x is 0. And then how low does it go and how high does it go? Yeah, so that arrow is not only going to the left, but it's going down and up. So negative to positive infinity. They both are going forever up and forever down. All right, let's do number 12. I like number 12. We'll come back to the more tricky ones here in a second. Number 12, how far left and how far right do we go? What's our farthest left? -4. -4. Farthest left? -4. How far to the right? 1. Brackets or parentheses? Other way around. Parenthesis for the 4. Why do we have a parenthesis there? Because it's an open circle there.
So it can't be.
Yeah, it cannot be -4. But negative 3.99999999999999999 is fine. Okay. All right. What about 1? What do we have at 1? Closed dot, so it's equal to, and so we use a bracket because it's a nice solid dot there. Okay. Range, how low does it go and how high does it go? What's our lowest y value? -8. 1, 2, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6, 7. -7. Right? Yes. All right. -7. And then how high does it go? 2. All right. Bracket or parenthesis at -7? It is a bracket. It's just a nice continuous, nice solid line. Okay. That's not a dotted line or anything like that. It is a nice solid equal to line. Okay. And then at 2, bracket as well. Again, because at 2, we have a nice solid dot there. So, perfect. Okay. 8 is tricky. We have an open dot here, so we have something to look out for. Oh, right there. Good. I'm ready. So we have an open dot here right in the middle of our graph. So if I'm talking about the domain, how far left, we're starting farthest left, how far left does this graph go? -infinity. And then it comes and it gets interrupted. It gets interrupted right here at what x value? -1. It got interrupted right at -1 because there's a hole in the graph. All right, so at -infinity we have a parenthesis. What do we have at -1? Parenthesis. Now we can pick up, so we're going to union. We're going to pick up on the other side. So on the other side of -1, which again just a parenthesis -1. So picking up on the other side, how far to the right do we go? Infinity. Okay, so this was how far to the left and how far to the right we go, except we got an interrupter. We got a hole in the graph. Okay, now the same is true for range. When we're going from how low do we go to how high do we go, it's being interrupted. So how low does this graph go? -infinity. And then as we move up the y-axis, where do we get interrupted? -3, right here. There's a hole in the graph when y is -3. So we have to take that out. So we use a parenthesis, union -3 to positive infinity, forever up. Okay? Do you kind of get that? Yeah? All right. Let's look at 11. 11, we have, what's going on? What do you see in this picture? A gap. You see a gap? Where's the gap? Right there. And when x is -1, there is this vertical asymptote right here where the graphs are going in different directions, okay? So again, there's this vertical asymptote where x cannot equal -1. So when we're doing our domain, Again, how far left and how far right does the graph go? Here's our graph. It's going forever. So negative infinity, and then we're coming along the x-axis, and where do we have a break? At -1, and we're going to union and pick up on the other side of -1, and we have a graph all the way to positive infinity. For range, how low does it go and how high does our graph go? Yeah, negative infinity. You can see our graph in multiple places is going down, 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 down. And then how high does it go? Forever to positive infinity. And number 10 is an interesting one. Again, it's about learning how to read graphs. Tell me what's happening here as we're moving to the left on this curve. It goes straight. Yeah, this is again a horizontal asymptote, kind of an interesting sort of thing here, where it is just running and it is going straight out to the left there. And that's happening when y is 1, 2, 3, 4, -5. So let's talk about domain. Domain is how far left and how far right does the graph go. This arrow goes on forever to the left, and this arrow goes forever to the right. So the domain here is negative to positive infinity. But the range is a little different. What is our lowest y value? -5. Now the question is, do we actually touch -5 or do we just get infinitely close? We get infinitely close to it, but we never actually equal -5 because there's an asymptote there that's taking up the space. But we are getting really, really, really close to -5. And then how high does our graph go? Infinity. Okay. All right. So the last thing here we want to talk about is no, not the last thing. I want to show you some technology quickly here. How much time do we have left? 56. Okay. So you do have some things with technology to graph, and so you might want to practice on your calculators. Finding domain and range with technology. So I just wrote a few examples down. You're going to see this in Delta Math. So graphing something like this, we know where our square root button is, hopefully. So square root of x minus 3, and then outside the radical we have a +2. Yeah? You good? You got it in? All right. And then let's just do a zoom standard. Most of these you're going to do a zoom standard window. So hit zoom and then scroll down to standard. Zoom standard. Good. And so we can look at this graph, and now that we see this picture, we can say, okay, great. So for the domain and the range, how far to the left does this graph go? Ooh. What's our farthest left x value? 3.
I forget that like
Our farthest left value is 3. Now the question is, is it a bracket or is it a parenthesis? It is a bracket. How are we sure? You can look at the table. You can also just press trace and type in 3. Trace and type in 3, and you see it 3, 2. There's an actual ordered pair there. God, that screen is terrible on this, isn't it? Okay. All right. So it is a bracket at the 3. How far to the right does it go? Infinity. All the way to the right. Beautiful. And that's parenthesis. Good. And then, so what is our lowest y value? 2. And we can see that right there when we hit trace and typed in the 3. So our lowest y value is 2. And what's our highest y value? Infinite. Yeah, it goes up above that forever. Perfect. Absolute value. So let's go back to y equals. clear that out. We have a negative, and then absolute value is in the math menu. So under the math button, which is right here, math button, and then if you arrow over to num, ABS is the very first thing. ABS is absolute value. So there's your absolute value, x, subtract 4, and then outside the absolute value is subtracting 2. Any problems? You got it? Zoom standard. So negative, you have to use the negative. There you go. Yep. All right, so do a Zoom standard. And, ooh, what shape is this graph? V, it's a V. It's an absolute value V. All right, domain, how far left and how far right does this graph go? Infinite, negative infinity to positive infinity. And how low and how high does it go?
Wait, doesn't it get interrupted?
It does not. And in fact, if you, we could change our window. So I want my y-axis to go much, much lower. If I can change the window and change my y minimum to like negative 1,000. All right. So here we go. Here's my curve now. Looks like a straight line. Maybe that is not a good choice. Negative, I don't know, I'll do negative 50. I don't want to be, oh, okay. All right. Oh, there. All right. So there's my V. Now it just looks really fat. But it does continue on forever. How low does it go?
Infinity.
Negative infinity. All right. And then what is our very highest Y value?
-2.
-2. And again, maybe we don't know, but I bet I can trace, and I'm just going to type in the 4, because I think it has something to do with my equation there. Look at that. And there it is at 4, -2. So -2 is the highest value, so we're going to use a bracket. Okay, last one here. I'm going to type in 3 to the x power, and then subtract 4. 3 to the x power. You do that with the little caret guy right above the divide sign to get the exponent. All right, and the Zoom standard. And domain and range. What's going on with this exponential function? Yeah, how far left and how far right does the graph go? Good. Negative to positive infinity. Yeah, what's the lowest Y value we get here? Let's see. I'm going to press trace, and you can see, yeah, as I'm moving down the curve to the left, my Y values are getting closer and closer and closer and closer to, but it won't be able to get there. So our lowest Y value is -4, but we cannot actually get there. It's going to be a parenthesis. And then how high does it go? Infinity. Okay. All right, questions on that stuff? Okay, great. So then, we have some questions in Delta Math about whether something is a function or not. So a function is a special type of relation in which each element of the domain is paired with exactly one element of the range. We can also change those words. Domain, you might use input, and range we could replace with output, okay? So where one input is matched with one output. And what we want to be careful of is that we don't have an input that splits and goes to two different outputs. That's the issue, okay? And so when I look here to determine whether this relation is a function, here I have an input of -3, and it's outputting a -4. -1 outputs a -2. 2 outputs a 1. 5 outputs a 4. Does each input have exactly one output? Yes. So then, yes, it is a function.
And then 14 wouldn't.
14 is not a function. Why? Yeah, -9 is going to -2 and to 5, and that is not allowed. that input has more than one output, and that's going to create confusion for us. So this is not a function. All right, what about 15?
No.
Where is the issue here?
Because at -5 and at -7 it's both.
So, but -7 is outputting a 2, and -5 is outputting a 2.
They have the same output, but not in.
Right, that's okay. This is fine. The input has one output. The input is not being sent to two different places. Okay? So this is, yes, this is a function. Graphically, we can use the vertical line test. The vertical line test is a nice way to determine whether or not something is a function. If a vertical line intercepts the relation at more than one spot, then it is not a function. And so if I were to sort of draw in a vertical line here, I can see that it crosses my graph just one time. So is this a function?
Yes.
Yes, it passes the vertical line test. All right, what about this one? No, if I draw a vertical line, it intersects here twice. All right. Does it do it at every single x value?
Wait, yes.
Actually not. Right here at the very tip of this curve, it actually only has one input and one output. And that one point is fine, but everywhere else, it is not a function. It fails the vertical line test. And what about 18? Does it? Yeah, this is a function. If you draw a vertical line, it only hits in one spot. So this is, yes, it's a function. It passes the vertical line test. Okay. Be careful when you go through these questions in Delta Math because they have some very specific word choices. So be careful as you're reading through those.